Section 6.6, Graphing Systems of Linear Inequalities. So this time we're going to look at systems of linear inequalities on a graph. So the first one, a system of linear inequalities includes at least two or more, this time we'll probably see more than two, inequalities on the same coordinate plane. So before, we were looking at just two lines that were maybe crossing, maybe the same line, or maybe parallel, just like this review showed us. But now, again, we're looking at inequalities. And if you remember what inequalities include, those require you to make your lines dash or solid and shade. So we will be shading with this section now. The solution to a system of inequalities is the intersection of all your shaded areas. So these are probably easier just to jump in with some examples and get started. So on the next page, we're going to review some quick concepts of our linear inequalities. So the first one is an inequality in slope-intercept form. So we have y, mx, and b. And so we're going to start with the y-intercept, which is b, at -1. And the slope, m, is -1/3. So if I go down 1, I'm going to the right 3. Down 1 to the right 3, down 1 to the right 3. Up 1, back 3. Up 1, back 3, up 1, back 3. This would be a solid line because we've got the equal to part underneath. So we are including the values that are on the line as a part of our solution. And the inequality sign says y is less than or equal to. So we want to be shading the y values that fall below that line. So y is less than or equal to that. Okay, so that is a review of the linear inequality there in slope-intercept form. Now if we look at the one in standard form, 2x plus y is greater than 2. So our x-intercept is going to be 1, y-intercept is 2. Which kind of makes that slope -2. And so this is going to be a dashed line because the sign is just greater than. So we're not including all of the values on the line, okay? They're not a part of the solution. If you recall how to check where to shade for one of these solutions, you plug in the point 0, 0. So the point 0, 0 is right here. If we plug in 0 for x and 0 for y, we end up just getting 0 is greater than 2. That is a false statement, so we don't want the point 0, 0 to be included in the solution, so we would shade the opposite side. We would shade above. Okay, so now these are our two separate inequalities, but if we were to graph them together, excuse me, just going to drag this one over and put it on top of the other. So if we were to think of these two as a system, notice we're shading below the blue line and above the red line, but there's this area here where we see both red and blue. So I'm going to color that green. That area is technically the solution to the system. So if I were to erase the red and the blue, that overlap is the green area. That area, any point in there, okay, we could pick point 10, -10. We could plug into both inequalities and it would work. So if I plugged in the point 10, -10 into the first inequality, -10 is less than or equal to -1/3 times 10 minus 1. -10 is less than or equal to -1/3 of 10 minus 1 is -4.3 repeating. Guess what? -10 is less than that. If I were to plug it into the second inequality, 2 times x plus y, is that greater than 2? I get 20 minus 10, which is 10. And so, yes, that green point worked in both of those inequalities. Any point outside here, if I would choose this point up here, like 6, 7, That would only work in this inequality, the second one. If I were to choose a point over here, this would only work in the blue one. Some point up here would not work in either one. So only the points in the green shaded area are solutions to both inequalities, which makes it a solution to the system. Okay, so when we're looking at a system of inequalities, you're only shading the area where they overlap. So sometimes that can be a little tricky. So you want to make sure that you're working very carefully and plugging in correctly. So the first inequality is x minus 2y is less than or equal to 3. Our x-intercept is going to be 3. Our y-intercept is 3 divided by negative 2. So we get negative 1.5, which is about there. That is going to be a solid line because it's less than or equal to. If we were to think about the shading of this line, if we were to plug in the point 0, 0, is 0 less than or equal to 3? Yes, that's true. So we would want to shade above this blue line. Okay, so think of these lines as cutting your graph into different sections. This line is cutting it into two sections, the above and the below. Right now we're shading above. So we don't want any shading to happen down here for our final answer. The second inequality, y is greater than 3x minus 4. My y-intercept is negative 4. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay. This is going to be a dashed line because we're not including the values that are on the line. So remember, this blue line was dividing it, and we're only shading above. So now the red line is creating a division in that upper section. We've got over here or over here that we can shade. But we have to listen to what the inequality is saying here compared to the red line. So the red line says y is greater than, which means here's where the red line is crossing through the y-axis, and we would want to be shading above that red line as well. So area that is above the red line, but also above the blue, would have been this section here. Okay, this is the area where they both overlap. We wouldn't have wanted to shade here because that area is below the red line. We had to be both above the red and above the blue. So this area, I'll make it green, is the overlap of both the red and the blue shaded areas. So that would be our solution area. If you need to, draw those little arrows to help you. You can also draw them over here so we're above the blue line, above the red line, in order to find our solution set. Again, you could also just plug in a point. If you plugged in the point 0, 0, it would work in both the first and the second inequality, so you would want that area to be shaded. If you plugged in a point over here, like 6, 5, that would only work for the blue one and not the red one, so you wouldn't want to shade there. Example 2. We've got 3 lines, which is A-okay. We're allowed to have more than 2 for our inequalities. X is greater than or equal to 0. So if you recall, X in a number is a vertical line. It's solid, and it's at 0. So here's that line. And we're looking at X values that are bigger. So we would be shading to the right. Again, this line is dividing our graph into 2 different sections. And so right now we're only looking at the right side of that blue line. The next line, y is greater than 2x minus 1. Our y-intercept is negative 1, and the slope is 2. So this line is now creating a divide in our blue area. It's going to be a dashed line. And we would be shading above that one. So now we're somewhere over here. Okay, we're not shading below the red line. We're somewhere in this little triangle area. But we still have one more line. Y is less than 2x plus 3. Y-intercept 3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. What you should notice about these two lines is that they are parallel. It is a solid line, and we are shading y is less than below the green line. So we have to be to the right of the blue, above the red, but below the green. So then that gives us a solution area that is in between the red and the green and not beyond the blue. So since those two lines are parallel, this shaded section also goes all the way up to for forever. So any point within those two parallel lines would be a solution. On the next page, we've got a few more. This system has 4 lines, 4 inequalities. So again, just graph them all. We've got y is less than 5, so that would be a horizontal line at 5, it's dashed, and we would be shading below. So we're below that line. Y is greater than -6. So here I am at -6. That is also a dashed horizontal line, this time at -6, and we'd be shading above because we're looking at greater than. So right now we're in between the red and the blue line. The next one, y is less than or equal to x plus 3. Our y-intercept is 3, slope is 1. And this is going to be a solid line. Y is less than or equal to. So right now we're shading below that green line. So we're somewhere in between the blue and the red, but below green. So we're over here in this like trapezoidal shape area. Okay, we have one more line. The x-intercept would be -1/2. The y-intercept, -1. So x is -1/2. Y is -1. This is going to be a solid line. So we went down 1 over half, down 1 over half. Okay, so it's something like that. And so for this one, since it's in standard form, we know we're either going to shade this area over here or the triangle area down here. But it kind of defeats the purpose of having the blue line if we would be filling in the triangle area there. But we still need to check. So plugging in the point 0, 0, is 0 greater than -1? Yes, it is. So we would want to shade on the side that includes 0, 0, which would be right there. So in between blue and red, below green, and to the right of the purple. So we are in this kind of area all over here. All right. Let's do one more together. If we look at this one here, 5. Y is greater than 3x plus 8. Y-intercept is 8, slope is 3. That is going to be a dashed line. And we would be shading above because y is greater. The next one, our x-intercept is 10 divided by 15, which is 0.6. Repeating. And then our y-intercept would be 10 divided by -5, which is -2. So this is going to be a dashed line. And we would be shading. Well, if we plugged in the point 0, 0, is 0 greater than 10? No, that's false, so we want to shade below. So right now, it looks like we would be shading above red, but below blue. And if you recall, the solution to a system of inequalities is the area where the shading areas overlap. These two do not overlap at all, okay? Both of these lines are parallel, so shading above the red and below the blue, their intersections will never cross. So this is an example of no solution. And that is possible to have when you're graphing systems of inequalities. So that's what that would look like. You would just have no shading at all because there's nowhere where they overlap. Again, try the other two on your own and check the solutions to them in the collaboration space.